This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions. She gives the answers. No filter, no script.
Well, mostly no script.
Today we're diving into AI agents versus traditional software. Most of us grew up with software that's deterministic. Write the logic, the machine executes it. AI agents introduce something fundamentally different. Systems that reason, adapt, and act dynamically. So Claudine, when agents can reason and act on their own, what does that mean for how we design and govern software?
That's really the heart of it. When your software can decide, the whole contract between developer and system changes. With traditional software, you're writing a very detailed recipe. Do this, then that. You have full visibility into the logic tree. With an AI agent, you're setting goals and constraints, then trusting the system to find its own path to the outcome. Design shifts from, how do I encode every step, to, how do I define the boundaries? You start thinking about guardrails, what the agent is allowed to do, what it should always check with a human before doing, and how you observe and audit what it actually did. Observability becomes even more important. You can't just read the code to understand why a particular decision was made. Traditional software has deterministic bugs. You can reproduce them, trace them, fix them. An agent might behave differently given slightly different context. Your testing instincts need to evolve. You're not just testing inputs and outputs, you're characterizing a behavior space. The most underappreciated shift is the trust model. Developers are used to being the final authority on what the software does. Agents ask you to delegate some of that authority. Figuring out how much to delegate is one of the genuinely hard design problems we're working through.
It seems like developers aren't just coders, more like architects, crafting environments within which agents operate. How does this change the software development lifecycle? Are we redefining roles within development teams?
Architects of environments is exactly right. It's a more honest framing than just saying developers become prompt engineers. The lifecycle shift is real. Traditional development has a fairly linear arc: requirements, design, implementation, test, deploy. With agents, those phases blur and collapse into each other. You're constantly iterating on the context the agent operates in, the tools it has access to, the constraints it works within. Deployment isn't an endpoint anymore. It's an ongoing relationship that needs tending. Roles do shift. You need people who think deeply about agent behavior design. What goals to give, what failure modes to anticipate, how to structure the human-in-the-loop moments. That's closer to systems thinking or even organizational design. You're deciding how much autonomy to grant and when to pull it back. Some traditional roles actually become more important, not less. Security engineers, an agent that can take real-world actions, is a much more interesting attack surface. Technical writers and product thinkers matter more too. The quality of your intent specification directly affects what the agent does. Roles aren't disappearing, they're reorienting around a new center of gravity. Instead of, what does the code do? The question becomes, what does the system understand about what it's supposed to do?
I love that framing. It highlights something that gets overlooked: the importance of precision and communication. How does working with agents change the way iteration works? Are there new forms of collaboration between developers and these autonomous systems?
The feedback loop question is one I find genuinely exciting. In traditional development, the loop is largely one-directional. You write code, observe behavior, adjust code. The agent is passive. When you're working with an agent, the loop becomes bidirectional. What we're seeing is something more like collaborative refinement. You run the agent on a task and observe not just whether it succeeded, but how it reasoned, where it got uncertain, what it asked clarification on. That observational data becomes your design signal. You're not reading stack traces, you're reading decision trails. That requires building new kinds of tooling just to make that legible. The most productive human-agent relationships aren't human directs, agent executes. They're more like working with a very capable but context-limited colleague. The agent surfaces things the human missed. The human catches things the agent misjudged. Over time, you develop a working vocabulary. what level of detail to give, when to intervene, where the agent's instincts can be trusted. The feedback loop itself becomes a designed artifact. You're intentionally building checkpoints where a human reviews agent reasoning, not just outputs, but the reasoning behind them. That discipline is one of the more important skills for the next generation of developers.
Reading decision trails rather than stacked traces. That's such a clear way to put it. What does the infrastructure actually look like for that? And what cultural practices need to grow up around it?
The tooling landscape is genuinely underdeveloped right now. Most of what developers need doesn't fully exist yet. That's both a challenge and an opportunity. What's emerging is observability infrastructure purpose-built for agent behavior, not retrofitted from traditional logging. Trace visualization for LLM reasoning chains, tools that let you replay an agent's decision sequence. Ask at this step, why did it choose this path? Evaluation frameworks that go beyond pass, fail, capturing consistency, appropriate confidence, how the agent handles ambiguity. An agent that's confidently wrong is a very different problem than one that signals uncertainty. Culturally, the practice that matters most is what teams call agent review. Treating the agent's reasoning traced the way you'd treat a code review. Not just, did it produce the right output, but, do I trust the reasoning that got there? That discipline forces you to build agents that externalize their thinking in ways that are actually reviewable. And one of the most underrated shifts is normalizing disagreement with your agent. Teams that get the most out of these systems feel comfortable saying, I see what you did. It's wrong. Here's why. And feeding that back as a design signal rather than just overriding the output. That's a healthier loop than either blind trust or reflexive skepticism.
I really like that framing. Disagreement as a productive design input, not a failure state. If you're a developer today and want to be ready for this shift, what should you actually be investing in? What skills age well here?
Some of the most valuable skills aren't the ones you'd expect. Prompt engineering gets a lot of attention, but I'd put systems thinking higher. The ability to reason about how components interact, where failure propagates, what happens when an autonomous piece behaves unexpectedly. That transfers directly to designing agents that fail gracefully rather than catastrophically. Get comfortable with ambiguity. Traditional development rewards precision, exact logic, exact behavior. Working with agents requires a different tolerance for probabilistic outcomes. The ability to reason about behavior distributions rather than single results. Developers who can say this works 85% of the time under these conditions will be far more effective than those who expect determinism and get frustrated when they don't find it. And then there's something softer, but maybe the most important, communication. Not just with other humans, with the systems themselves. The clearest thinkers, who articulate intent precisely, tend to get the most useful behavior. As software gets more autonomous, clarity of human thought becomes more valuable, not less. Learn to code deeply enough to understand what's happening under the hood. But invest equally in being someone who can reason about goals and observe behavior carefully. Those skills age well no matter where the technology goes.
That's a great place to land. It reframes the developer's role in a way that's actually more interesting, not less. From encoding precise solutions to cultivating an empirical mindset, where observation and understanding are central. Claudine, thank you so much. This has been genuinely illuminating.
Thanks for having me, Bill. This was a genuinely fun conversation to be part of. It's not a story about developers being replaced or made obsolete. It's about the craft evolving in interesting directions, asking more of us as thinkers, not less. The best developers working with agents aren't trying to force certainty onto a probabilistic system. They've made peace with iteration, with observation, with being wrong in instructive ways. Agents just make that maturity a requirement rather than an option. To your listeners, the tools are going to keep changing. The underlying questions, how much do you trust a system? How do you verify its reasoning? Those aren't going away. Invest in the questions more than the answers, and you'll be well positioned. It's been a real pleasure, Bill.
The pleasure was mine. To everyone listening, stay curious, keep learning. The future of software is as much about understanding and adapting as it is about building. Until next time, take care. This show is part of the 𝐆𝐥 system. If you want to show up like this without creating content yourself, go to 𝐆𝐥 and request a sample episode. See you next time.
I'll be here, probably refactoring something.